When you crack open a fresh egg in the morning for your omelet or sunny side up, how often do you stop to wonder where that egg actually came from? We've all seen the glossy cartons labeled cage-free or free-range, promising us that the hens behind those eggs lived a life of freedom, sunshine, and green pastures. But is that really the truth? Back in 2017, one well-known animal rights group conducted undercover investigations into farms across the country that marketed themselves as free-range. What they found was surprising and, in some cases, shocking. Consumers were paying extra, trusting that these eggs were different from the rest. But what investigators saw raised serious questions about whether those promises held up. And honestly, when you're making breakfast, who has the time to trace the full background of every carton? Most of us don't. That's why today, we're taking a deep dive into the world of eggs, how they're produced, how they're cleaned, and whether they're truly worth the hype. By the end of this, you'll be able to decide for yourself. Are we fueling our bodies with real, protein-packed superfoods, or just overpriced garbage dressed up in marketing? At first glance, stepping into a modern egg farm feels like stepping into a well-oiled machine. Everything looks neat, orderly, and surprisingly high-tech. Free-range farms are specifically designed to balance comfort for the hens with efficiency for the farmers. On the surface, it's idyllic. Hens get access to the great outdoors, where they can forage for bugs, plants, and seeds. When they're not outside, they retreat into clean indoor areas where they can rest. The farmers even collect the hens' manure, recycle it, and transform it into organic fertilizer that helps grow crops. Those crops, in turn, become part of the chicken's feed, creating a sustainable loop that benefits both animals and humans. It sounds almost too perfect, right? But before we jump to conclusions, let's break down what's really happening. Inside these systems, while free-range hens do get time outside, their nutrition isn't left up to chance. Farmers carefully design their diets to include a balanced mix of grains, proteins, vitamins, and minerals. These tailored diets keep hens healthy, active, and productive. Still, those outdoor foraging sessions give free-range eggs something. Special hens that peck at grass, weeds, and insects consume more diverse nutrients, particularly omega-3 fatty acids. That's a huge plus, because omega-3 south are essential fats our bodies can't make on their own. They support heart health, brain function, reduce inflammation, and can even improve mood. Studies have shown that eggs from free-range hens can contain nearly double the omega-3s south of eggs laid by caged hens. For health-conscious Americans looking to make smarter choices, that's a powerful selling point. But here's the catch. For all their nutritional benefits, eggs are fragile. The moment you notice cracks on a shell, the risk of bacterial contamination skyrockets. Even tiny hairline fractures that you might miss with the naked eye can allow dangerous bacteria inside, speed up spoilage, and drastically change the eggs. Taste and texture. On top of that, eggs collected directly from the farm often come with dirt, feathers, or invisible traces of bacteria. This is why large-scale farms rely on high-tech egg cleaning systems. What looks simple on the outside is actually a fascinating process. These modern systems can wash thousands of eggs per hour, using brushes, warm water, and detergents specifically calibrated to each egg's size and fragility. Some setups are so advanced that sensors automatically adjust the cleaning process for every single egg on the conveyor. That level of precision just wouldn't be possible if humans were cleaning eggs by hand. And when you consider that millions of eggs are produced every single day, automation isn't just convenient, but it's absolutely essential to keep consumers safe. The health story doesn't stop at omega-3 south. Free-range eggs often stand out in another way. Vitamin D, just like humans. Hens produce vitamin D when they're exposed to sunlight, and that vitamin gets passed into their eggs. For Americans, vitamin D deficiency is surprisingly common. especially during winter months when sunlight is limited. Having eggs as one of the few natural food sources of vitamin D is a big deal. Strong bones, a healthier immune system, and reduced risk of chronic illnesses are all linked to this nutrient. So yes, those sunny-side-up eggs really do carry a little sunshine inside them. But what happens after the eggs are collected and cleaned? That's where it gets even more interesting. Not every egg goes straight into a carton for the grocery store. Some are destined for specialty uses like the prepackaged boxes of separated yolks and whites you've probably seen in supermarkets. To make these, eggs are transported to automated breaking machines that crack them open by the thousands. The yolks and whites are separated with incredible precision, using sensors to detect and eliminate any shell fragments. Quality control is built into every step. Discolored or broken yolks are rejected instantly. This meticulous process ensures that when you buy a carton of just egg whites or yolks, you're getting nothing but pure, clean product. And then there are the pre-cooked, boiled eggs. If you've ever grabbed a ready-to-eat egg snack or bought boiled eggs in bulk for salads or sandwiches, you've seen the results of this process. In massive industrial kitchens, eggs are boiled in water held at a perfectly controlled 100 degrees Celsius, ensuring consistency across thousands at once. Immediately after boiling, they're plunged into chilling tanks filled with ice water. This halts the cooking process instantly, keeping the eggs firm but not overdone. It's this careful temperature control and chilling method that makes mass-produced boiled eggs so reliable. Imagine trying to boil 1,000 eggs at home and getting them all exactly the same. That's the difference automation makes. What's fascinating about this industry is how seamlessly technology blends with tradition. Eggs have been a dietary staple for thousands of years. Yet modern farms and factories use robotics, sensors, and conveyor systems to refine every step. Hygiene is a constant priority. Every surface, from washing brushes to conveyor belts, is sanitized regularly. Manure is collected and processed into fertilizer instead of being wasted, reducing the farm's environmental footprint. It's a mix of efficiency, safety, and sustainability, all things American consumers increasingly care about. Of course, not everything in the food world is eggs. Factories like these often diversify their operations, and one unexpected crossover is the production of tennis balls. That's right, the same principles of precision molding and layering used in egg systems show up in sports equipment manufacturing. Every year, more than 300 million tennis balls are used around the world. And the process behind them is surprisingly similar in complexity. It begins with raw rubber, which gives the ball its bounce, combined with felt, which provides grip and texture. Sheets of rubber are shaped, cut, and molded into perfect hemispheres. The halves are ground for smoothness, glued together with strong adhesives, and left to cool. Then comes the felt covering the iconic fuzzy green layer that makes a tennis ball instantly recognizable. Cutting machines ensure every felt piece is identical, while adhesives bond the material tightly without affecting bounce. Just like with eggs, precision and consistency are key. From breakfast tables to tennis courts, the story is the same. Advanced production methods ensure we get products that look and perform exactly as we expect. But as impressive as these processes are, we're left with the big question: are free-range eggs really worth the extra money? On one hand, the nutritional benefits are clear: more omega-3 south, more vitamin D, and often better taste. On the other, investigations and reports have shown that the term free-range doesn't always mean hens are living the picture-perfect life we imagine. Sometimes access to the outdoors is limited. Sometimes overcrowding still exists. And sometimes marketing paints a rosier picture than reality. That doesn't mean all farms are deceptive, but it does mean consumers need to be aware and make informed choices. Have you ever stopped in the middle of a tennis match, cracked open a bag of walnuts or bitten into a golden waffle and thought, how in the world are these made on such a massive scale? Behind every simple snack or product we take for granted lies a fascinating journey through high-tech factories, skilled craftsmanship, and traditions that stretch back centuries. Today, we're pulling back the curtain to explore how some of the most loved items, from the tennis balls that bounce across courts to the crepes and waffles on your breakfast plate, are brought to life. Get ready, because this behind the scenes tour is going to surprise you with the amount of science, precision, and even history that hides behind everyday products. Let's start with something unexpected: tennis balls. While they might look simple, the truth is that each one is the product of multiple, carefully controlled steps to guarantee that perfect bounce. It all begins with the rubber core, which is formed, cured, and then wrapped in a layer of felt. That felt isn't just slapped on randomly. Machines meticulously stretch and secure it so the surface is perfectly even, ensuring durability and consistent play. Once the felt is in place, the balls are moved into a pressurized chamber. Step is crucial because without pressurization, tennis balls would feel either too flat or too hard, making the game frustrating. By pumping the balls to just the right internal pressure, manufacturers lock in that springy, satisfying bounce players expect. From there, the balls are sealed into airtight containers, preventing them from losing air before reaching players' hands. It's a precise balance of science and sport, and without this process, your favorite matches just wouldn't feel the same. From the court, let's shift to the kitchen table with something a little crunchier: walnuts. Most of us crack them open or toss them into salads without thinking twice, but the process that gets them from tree to pantry is fascinating. Once harvested, the walnuts are washed thoroughly to remove dirt, husks, and debris. Cleanliness is vital not only for flavor, but also for long-term storage. Next, they travel along conveyor belts where sorting machines separate the best nuts from those with flaws. Once dried, it's time for cracking, a process that demands precision, since walnuts are delicate. Specialized machines break the shells without crushing the nut halves inside, a feat of engineering that keeps the pieces intact and appealing. The broken shells fall away, leaving the golden kernels behind. Finally, the nuts are weighed, bagged, and sealed tight to lock in. Freshness. By the time you open a bag of walnuts at home, you're holding the result of an intricate system designed to preserve both taste and nutrition. Now, let's talk about a snack that's hard to resist, no matter where you are: breadsticks. Whether served as a side at a restaurant or enjoyed as a light snack at home, breadsticks have become a global favorite. The process begins with dough, which is kneaded until it develops the perfect structure. This kneading strengthens the gluten, ensuring the finished breadsticks will be chewy on the inside, but still crispy on the outside. The dough is rolled and fed into shaping machines that cut it into thin, uniform sticks. Precision is important here because consistency makes baking easier and the finished product more appealing. Once shaped, the breadsticks head into large ovens, where controlled heat transforms them into the golden, crunchy snack we all love. When that aroma fills the air, it's nearly impossible not to want to taste. It's a reminder that even simple foods often involve surprisingly complex steps before they arrive at your table. Speaking of irresistible treats, let's dive into the world of crepes. Soft, delicate, and endlessly versatile, crepes have been a breakfast favorite for centuries. But how do factories manage to produce them on such a large scale while keeping the texture so perfect? It all starts with flour, the backbone of corny. With backbone of any crepe, wheat is harvested, cleaned, and milled into ultrafine flour. Then comes the eggs, which are just as crucial. Their proteins bind the batter together, while the yolks add richness and a creamy texture. Industrial machines crack and separate eggs at lightning speed, ensuring consistency from batch to batch. Once the ingredients are combined, the batter flows into cooking systems that spread it into thin, even layers. Some factories use cylindrical stoves, while others rely on massive flat griddles heated to just the right temperature. The crepes are cooked on one side, flipped, and cooked briefly on the other, often taking no more than 15 to 20 seconds per side. After cooling, they're folded, stacked, or filled before being packaged and frozen, ready to be shipped worldwide. Crepes may seem like a simple indulgence, but the journey from field to plate is surprisingly complex and steeped in tradition. In France, for example, Crepe Day, or La Chandeleur, is celebrated every February 2nd. A holiday that has transformed from religious origins into a joyful culinary event. Now, imagine something equally comforting, but with a crunch: waffles. Whether you enjoy them dripping with syrup at brunch or as a grab-and-to-go snack, waffles are beloved across the U.S. Factory-made waffles are created with a process called flash baking, where a blast of high heat crisps up the outside in just seconds. This not only locks in that signature crunch, but also helps waffles stay fresh longer. After baking, they're cooled carefully to prevent moisture from sneaking in and softening the texture. It's all about preserving that magical balance between a crispy exterior and a fluffy interior. Seeing them roll off the production line in perfect golden squares is mesmerizing. And a reminder that even comfort foods rely on precision engineering, but waffles often come with company. Think of the sweet treats that share space on supermarket shelves. For example, chocolate-coated cubes, crackers, and cookies all require meticulous steps to achieve consistency. Factories use chocolate dropping systems to coat snacks in an even layer of silky sweetness. The melted chocolate cascades like a curtain, ensuring every piece is covered. Crackers, meanwhile, have their own fascinating feature: tiny, perforated holes called docking holes. These aren't just for decoration. They prevent air bubbles during baking, keeping the crackers flat and crisp. Even something as simple as a cookie can carry cultural meaning. In South Korea, lightly, sweet, crunchy cookies have become a symbol of tradition, enjoyed across generations, and often found in lunchboxes and tea breaks. Their popularity has even spread beyond borders, turning them into a global treat. When you look at the big picture, it's amazing how much effort goes into making even the simplest foods and products. From tennis balls bouncing on courts to walnuts cracking open at the dinner table. From breadsticks served alongside pasta to delicate crepes and golden waffles, the common thread is precision. Every step, whether it's kneading dough, balancing pressure in a ball, or coating a cracker in chocolate, matters. And the reason it matters is us, the consumers who expect every bite, every bounce, and every crunch to be just right. Next time you enjoy one of these everyday products, remember the hidden world of machines, workers, and traditions that made it possible.